Maths is all around us. It makes our buildings, structures strong or weak. It programs our computers and helps us understand things larger than ourselves. Maths is involved in many different aspects of science, especially physics. We can work out using mathematics how many things happen, but it can also help us understand what can go wrong.
Escape velocity is the speed in which an object must go in order to escape or orbit a larger body of mass. This can be worked out by the formula VE equals the square root of 2mg over r, where VE is escape velocity, m is the mass of the planet, g is the universal gravity constant, 6.67 times 10 to the power of negative 11, and r is the radius of the object.
For an object to escape Earth, it must be travelling at least 11.2 kilometers per second. We can work this out by substituting the Earth's mass, which is 5.97 times 10 to the power of 24 kilos, and the Earth's radius, 6,378,100 meters for r. We get our answer by finding the square root of 2 times the universal gravity constant times the mass, divided by the Earth's radius, which roughly equals 11.2.
After we figure this out, to launch an object off the Earth, say a tennis ball, it will need to travel at least 11.2 kilometers a second. A rocket will also need to be launched at 11.2 kilometers a second to escape Earth's gravity without orbiting. No matter how heavy or large an object is, it would always need to be traveling at the same speed to escape the Earth's gravity, but the force needed for it to reach that speed will vary for different objects.
Take the Sun for example. It has a mass of 1.989 times 10 to the power of 30 kilos and a radius of 695,700,000 meters. So the square root of 2 times 1.989 times 10 to the power of 30 kilos times 6.67 times 10 to the power of negative 11 divided by 695,700,000 meters equals roughly 618 kilometers per second. It takes an F1 car about 2 hours to travel that same distance.
Sirius A is a white dwarf star, the brightest star in the night sky, which has a mass of roughly 4.018 times 10 to the power of 30 and a radius of 1,405,314,000 meters. So the square root of 2 times 4.018 times 10 to the power of 30 kilograms times 6.67 times 10 to the power of negative 11 divided by 1,405,314,000 meters equals roughly 118 kilometers a second.
The escape velocity of Sirius A is the same as the Sun's escape velocity because the radius and the mass of Sirius A is about twice as large as the Sun's, and since you divide the radius from the other numerals, it keeps the equation the same.
A black hole has an unlimited amount of mass at any point in the center, the event horizon. This means that the mass is equal to infinity, thus the escape velocity is greater than the speed of light. This is why black holes aren't able to be seen because not even light can escape.